Okay, so addition reactions. What is the condition for addition reactions? What molecules will have addition reactions? Alkenes and alkynes. So I can say addition reactions involves unsaturated hydrocarbons. So the site of the double bond and the site of the triple bond is a reactive site. The bonds can easily be broken so that you can add atoms onto the carbon chain. So first of all, we're going to take an alkene and we'll add to it hydrogen. What do you think will be made? Think. If you add hydrogen to an alkene, what do you think will be made? You are adding hydrogen. You'll make an alkane. You'll make an alkane. Wait, look, you can copy later. Look. So let's take a simple alkene like ethene. This is the structural formula for ethene. Yes? This double bond is a site for reaction. Okay? You can break one of these bonds and you can add atoms to it. So the hydrogen's Cooper structure looks like this. Okay? It will break this bond so that this carbon can take another atom and that carbon can take another atom. Where will those atoms come from? Those atoms will come from splitting the hydrogen molecule into two. So that will give us a saturated hydrocarbon. Now, the double bond is not too difficult to break. But to break the hydrogen, we need something. What do we need? There, I gave it to you in a bubble. What do you need? You need a catalyst. You need a catalyst and you need a non-polar solvent. So these things are conditions. Why do you think we need a non-polar solvent? Yes. Yes.
So does it can you find something only like something that they're the same like
yes. And this one's got London forces and hydrogen's got London forces. So we need a non-polar solvent that will bring these two, the alkene and the hydrogen, into a mixture. You get it? So this must create a mixture. Okay, so once you break the double bond, which is not too difficult to break, the collision between the molecules can break the double bond. That molecule is now reactive. It will attack the hydrogen, break the hydrogen's bond. It's magic. It's magic. So you take an alkene, which is unsaturated, and you now make an alkane, which is saturated. You have now changed the mass of the molecule. you have added to the molecule. That's why it's called an addition reaction. And adding hydrogen is what? Hydrogenation. So this special addition reaction is hydrogenation. Adding hydrogen. So it's addition of hydrogen. You wanted to ask?
Ma'am, so going back to the combustion reaction.
Okay. So to use condensed structural formula, what would it be? CH2 plus H2 goes to CH3. Or molecular formula, C2H4 plus H2 goes to C2H6. Shumani.
Can you say that hydrogenation, let's say that hydrogenation is the process that happens when an alkene reacts with a hydrogen?
Also when an alkyne reacts with an hydrogen. Yes, unsaturated hydrocarbons. You must know the conditions. Sorry. You must know the conditions. The conditions is what I've written there. That you must use a catalyst and a non-polar solvent. Did they mention possible catalysts? Platinum. Yes, there I did. Palladium or nickel. We're done with combustion, we're doing addition. Hydrogenation is the process where you're adding hydrogen to an unsaturated hydrocarbon.
Wait, let me just clarify. The hydrogenation is the process of unsaturated compounds reacting with hydrogen.
Yes. Is the addition of a hydrogen halide. So that is your HX, like your HF, your HCl, go away, your HCl, your HBr, and your HI. Those are the HXs. Okay, so you have an unsaturated hydrocarbon. Let's go for a more challenging one. Let's go for 2-butene. And which one of the four do you want to use? Hydrogen iodide. So what will you make when you take an alkene and you add an hydrogen halide? what will the compound that is formed be? Haloalkane or an alkyl halide. Okay, so what will this be? Iodo, butane. You saturate it. The double bond breaks. Where will the iodine join? On the first, second, third, fourth carbon. Which one? So this would be 2-iodobutane. I'm telling you, you're mixing the alkene with hydrogen halide. That's what I'm telling you. Like in the first one, I told you that the alkene is mixed with hydrogen. Now I'm telling you the alkane is mixed with the haloalkene. The alkene is mixed with hydrogen halide. I'm telling you, that is it. Yes.
So the reason for the true iodobutane is because the carbon...
The double bond is on the second carbon. Yes.
So basically in addition reactions, there's no need for balancing.
No. You're right. Okay, so let's use the structural formulas to organize ourselves. So 2-butene would have the double bond in the middle of the molecule. Am I right with that?
Yes.
Okay, so here we go with all our hydrogens that we still need to add here. And our hydrogen halide is the HI. Now, here the condition, the only condition is that there should not be any water present. I see I left it off my note. No water. There must be no water. That is just a condition for the reaction to take place. So, this double bond will break and become only a single bond. Yes.
What's the polarity of HI?
What do you think is the polarity? Can we work it out?
I would be 2.1 minus, oh, it's 0.4. So that's like non-polar. I said it's non-polar.
Non-polar. Okay. 0.4. There is a slight polarity. Maybe that's why the HI will attack the double bond. Okay? So the second carbon needs another bond. I can put the hydrogen on there. But I can also put the iodine on there. Doesn't matter. Okay? And this carbon needs another bond. If I choose to put the hydrogen on that carbon, then I must put the iodine on the second carbon. And I would number these carbons then from this side if I place the iodine on that carbon. So that it would be 2-iodobutane. Yes.
This type of addition reaction, is it called the hydrohalogenation?
Yes. So this one is called hydro, because you're adding hydrogen, halogenation. Because you're adding the halogen. So in the previous one we only had hydrogen atoms adding to the molecule, so it is hydrogenation. In this one we're adding a hydrogen as well as an halogen, so it's hydrohalogenation. There is a pattern in here, but it takes some time to get to know it.
Yes, please.
Reaction number 3 is addition of halogen. So you could have the addition of halogens would be F2, Cl2, Br2, and I2. Now here, this is a favorite question because bromine has a brown color and iodine has a purple color. Yes. So what happens is you'll see that we're going to compare the reaction between an alkane and an halogen and the reaction between an alkene and a halogen. And the reaction between the alkene and the halogen is much faster than the alkane and the hydrogen because you've got this double bond. And the reason why we can see the reaction is the brown color disappears or the purple color disappears. So the reaction is a fast reaction. What do they say? For halogenation, no conditions whatsoever. So there are no conditions here.
The UV from sunlight.
No, wait, the sunlight story is something else. What did they say there?
No, it just says like UV from sunlight.
No, that is with substitution. We'll get to that one. Okay, so an alkene plus, look at my spelling. An alkene and an halogen will give you what? Okay. Which one do you want to use? Fluorine. Fluorine. Okay. And the alkene you want to use? No, this is halogenation. Propene. Like that. Is that propene? So what will form? Okay, let's see. Let's use this. So if the double bond breaks here, if this double bond breaks, then this carbon will have space for another atom and that carbon will have space for another atom. So we will have 1, 2 difluoropropane. Yes, it changes to a saturated carbon chain. So this is 1, 2 difluoropropane. Structural or condensed structural formula CH2CH CH3 plus F2 will give you CH2F CHF CH3. And this reaction is halogenation. So the first one was hydrogenation, then we get hydrohalogenation, and now we've got halogenation, addition reactions.
Please unlabel the